Welcome back. Today we are going through lesson 13.4, which is all about graphing our trig functions. And so let's start off with some definitions here. Trig functions are what we call periodic functions. So that's where we have a repeating pattern going on in our graphs. And the shortest pattern, so the beginning to end of one pattern, is called a cycle. So within those periodic functions, we have two key things that we need to talk about, the period and the amplitude. So the period is the horizontal length of each cycle. So how far across our x-axis that it is extending from the beginning to end of one cycle. And the amplitude is half of the distance between the maximum and the minimum values. So we're going to look at kind of what these look like in terms of our trig functions. We have a sine and a cosine parent function. So we can see, hopefully, that sine and cosine look similar, but they're not in the same place. So the sine function goes through 0, 0, whereas the cosine function has its maximum at 0. So it looks similar, but it's shifted one way or the other, depending on whether it's sine or cosine. So let's look at the domain here. So the domain for both functions would be negative infinity to positive infinity. It's a continuous graph from left to right, never stops. The range, if you look at both of them, the lowest to highest, so the lowest both of them goes down to is -1. The highest both of them go up to is +1, and that's because of that radius of the unit circle. So the range is -1 to +1. The period, so remember from our definitions above, the period is the horizontal length of one cycle or each cycle. So if we're looking at the period here, if we go for example, on sine, from where it starts at 0, 0, it goes up to a maximum, down to a minimum, and comes back to that horizontal axis at 2 pi. Same thing here. So in the cosine function, it starts at a high point, goes down to a minimum point, back up to its high point at 2 pi. So the period, or the length of one cycle, is 2 pi for both functions. All right, and then the amplitude. Remember, the amplitude is half the distance between our min and our max. So halfway from -1 to +1, that's 2. So half of that is an amplitude of 1. All right, and then lastly, some key points on here. So the sine function has x-intercepts. We know it starts at 0. And then the next time it crosses that x is at pi or -pi. So I'm going to write that as plus and minus pi. So it's going in both directions. And then it continues to cross that axis at every multiple of pi. So it crosses at plus and minus 2 pi. If it continued, if our graph was longer, it would cross at plus and minus 3 pi, and so on. So all the multiples of pi is where the x-intercepts for sine are. For cosine, it's a little bit different. So for cosine, we can see that we have one at pi over 2 and -pi/2. So plus and minus pi/2. And then out at 3 pi/2 and -3 pi/2. And then it keeps going. So it's all the odd multiples of pi/2. So 1 pi/2, 3 pi/2, 5 pi/2. It would go again at 7 pi/2, and so on. So those are the x-intercepts, some of those key points. Okay, let's look now. If we want to change anything about this, so stretches and compressions, we would do that by multiplying by this a value out in front. So if we have something in front of our sine or cosine function that's being multiplied, that is going to change the amplitude, so that height. So if we have that a value, the absolute value of that a value is how the amplitude changes. So it might go from 1 stretched up to 2, or maybe it gets compressed down to 1/2, whatever that a value is. It's going to change the amplitude by that amount. If the period changes. So if it gets stretched or compressed outward in the x direction, that happens because of b. So the b value is a number that's multiplying by the theta from the standard spot. So b is the number of cycles that happen between 0 and 2 pi. In our parent functions here, we know that between 0 and 2 pi, 1 cycle happens. So if that changes because of a b value, that means that we're going to have more or less cycles happening between 0 and 2 pi. So we would find that change by doing 2 pi over the absolute value of b. So that b value is what's going to affect whether that cycle gets shorter or longer. So when those things happen, we may have some changes in our intercepts and maxes and mins. So x-intercepts, if we have an a value or a b value in there, it could change. So the x-intercept of 0, 0 is not going to change just because 0 times anything is still 0. So that's not going to change. Then what's going to happen is the next one is going to happen at 1/2 times 2 pi over b. And then the one after that is going to happen at 2 pi over b. For cosine, instead of 1/2, it's going to be the multiples of 1/4, because remember that doesn't start at 0, 0. So these are going to be at 1/4 times 2 pi over b. And then the odd multiples again, so 3/4 times 2 pi over b. And then it would continue on with those odd ones. All right, our max and min. Our max and min are going to change when the amplitude changes. So maximum on the sine function happens in between those x-intercepts. So that would be at 1/4 times 2 pi over b. And now the amplitude is going to be whatever that a value is. The minimum, remember it goes up and then comes back down in the sine function, so the minimum happens at the next point after the x-intercept. So that's going to be at 3/4 of 2 pi over b. And it's going to be in the negative direction of a, whatever that a value is. All right, for cosine, remember those maxes and mins are in slightly different points than on the sine function. So for our cosine function, that max is what it starts at. So it's going to be at 0, and it's going to be as high as whatever a is. And then it happens again after a full cycle. So 2 pi over b, and then the a value again for that maximum point. So it has 2 maximum points within that one cycle or that one period. The minimum happens in between those. So that's going to be at 1/2 of 2 pi over b. And then the minimum, of course, is going to be in the negative direction of a. All right, so those are the key features of our sine and cosine functions. Let's look now at our tangent function. So the graph of tangent function looks a little bit different. It's still that periodic function where it repeats over and over again. We want to remember that tangent is the sine divided by the cosine. So because of that, since we're dividing by cosine, the cosine of x can never be 0. So we end up with these things called asymptotes. So if we were going to divide by 0, it creates a spot on the graph that's never going to be crossed. So anywhere that the cosine would equal 0, remember that is where we're going to end up with some vertical asymptotes. So those are some kind of key differences in the tangent function that we didn't have on sine and cosine. So the domain for this function is, again, it's that continuous function from left to right, except it has those asymptotes. So it is all real numbers except, so minus any multiples of pi over 2. Because those multiples of pi over 2 is where we're going to end up with those asymptotes. You can see it in our graph of our parent function, right? Pi over 2, 3 pi over 2, all those odd multiples are going to end up with asymptotes at the range. So the range on this one, notice it goes down forever, up forever. So the range on this one is negative infinity to positive infinity. The period, so if we look at how long it takes to create one full cycle, it goes from pi over 2 to 3 pi over 2, or a length of pi. Now for tangent, since it goes up and down forever, there is no amplitude. Just because it goes up and down forever, so it doesn't have that height to take half of. The x-intercept, so if we look at our graph here, we can see those x-intercepts happening at negative pi and 0, and it just keeps going with multiples. So it starts at 0, 0. It has one at pi, and then it has one 2 pi, and it would keep going forever and ever. All right, so let's see what happens when we stretch and compress that tangent function now. So the period changes that same way. So our period is pi in the parent function. So it would change by the absolute value of b. Remember, b is what we're multiplying that theta by. Those vertical asymptotes, depending on how it's stretched or compressed in the horizontal way, that's going to change our vertical asymptotes. So that is going to take those odd multiples of pi and divide them by 2 times the absolute value of b. So our asymptotes, if we have a stretch or compression with b, is going to change where those asymptotes lie. All right, and then our halfway points. So those are the points that are halfway in there. So those are going to happen at pi over 4b. And then the a values. Remember, the a value is being multiplied out in front. And it's also going to happen at the negative of that. So at negative pi over 4b and negative a. So that's how we kind of find that lower end of it. Okay, so we've got our 3 basic functions, sine, cosine, and tangent. Let's look a little bit at the 3 reciprocal functions and what they look like. So you can kind of see, hopefully, that what's happening here with the reciprocal functions is they're kind of graphing the reciprocal. They are graphing the reciprocal of the original function. So remember, the sine graph started here at 0, 0 and goes up and then comes back down and then goes down. So if I drew that on there, you would kind of see that it's flipping those. It's reciprocal of those. So that's what's going on there. So the graph of cosecant looks like those U shapes. And then same thing for the secant function. But again, the secant function is centered differently than the cosecant function because of those values. And then the cotangent function, you can see there, it's that reciprocal function of tangent, still with vertical asymptotes. So let's look at some key points here. So for cosecant, we know that the domain on this one, if we look at our graph, it's no longer continuous like sine was. It's got some gaps in there. So those gaps are those asymptotes that are happening again. So if we look at where those are happening, they're those multiples of pi again. So the domain for cosecant is all real numbers except or minus multiples of pi. Because of those asymptotes. And then the range is kind of funky on this one too. So the range is everything except between -1 and +1. So there's nothing happening between -1 and +1. So this would be all the y values less than or equal to -1 and all the y values above +1. So kind of a weird range there because it's missing that middle section. Again, because it goes up and down in the positive and negative direction, it has no amplitude. It doesn't have those maxes and mins like the other ones did. The period is still 2 pi, so it still takes 2 pi to complete one whole cycle. And then our asymptotes are going to happen those same kind of things, but with cosecant, it's going to be a times the cosine of b theta. And when that is 0, that's when we're going to get asymptotes. All right, now looking at secant. So secant is that graph up here. So if we're looking at the domain and range here, the domain, you can see, again, we have some asymptotes going on. So those are going to be at all the multiples of pi over 2. So the domain is all real numbers minus where those asymptotes are happening. So minus the odd multiples of pi over 2. So it's happening at pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. The range on this one is going to be the same as cosecant was. It's everything outside of -1 to +1. So all the y values less than -1 and all the y values greater than or equal to 1. It also does not have an amplitude because it's going up and down towards infinity and negative infinity. Its period is still 2 pi though. And those asymptotes are going to change based on those transformations, and they're going to be when the value of a times the sine of b theta is 0. So that's what's going to create asymptotes on our graph. Okay, and then our cotangent graph. So remember, our cotangent graph is the one that looks like that. The domain of that one, again, we have asymptotes going on, and I can see that those are happening at the multiples of pi. So this is going to be all real numbers minus multiples of pi. The range on this one actually does go up and down forever with no gap, so negative infinity to positive infinity. And then again, the graph is going up and down forever, so there is no amplitude. So no amplitudes on any of these reciprocal functions. The period on this one, so the time it takes to complete one whole cycle, so between two asymptotes, is pi for cotangent. And then again, our asymptotes here are going to happen at all the multiples of pi over the absolute value of b. So those transformations that are happening, stretches and compressions, will affect where those asymptotes happen. All right, we are going to jump into graphing some of these functions. So we're basically going to do one of each type of function. So in this first example, we have 1/2 sine of 4x. So remember, that means that a is 1/2 and b is 4. So that will help me kind of figure some things out. All right, so our amplitude for our sine function when it has a stretch or compression is the absolute value of a. So in this case, that would be that 1/2 value. All right, and then the period of this function. So the period, remember, when we have a b value, is 2 pi over the absolute value of that b. So that comes out to pi over 2. And we're looking at our intercepts. So our x-intercepts for sine are going to be at 0, 0. And then we have to do that 1/2 times 2 pi over b. So we already know that 2 pi over b is pi over 2 from the period. So that means that half of that is pi over 4, 0. Then continuing on, my next one would be at pi over 2, 0. So I know that it has x-intercepts here at 0, 0, pi over 4, and pi over 2, because remember, it is going to complete an entire cycle in pi over 2. All right, my maximum and minimum here. So the maximum we find by doing a fourth of 2 pi over b. So that would be pi over 8. And then the a value is how high it is. So it's at a half. And then the minimum on this one would be at 3 pi over 8. And it would be down at negative 1/2. So let's plot that max and min. So the max is over at pi over 8, up at a half. And the min is over at 3 pi over 8, which is halfway between pi over 4 and pi over 2. And it's at negative 1/2. So my sine curve looks something like that. And then obviously it would continue on if we wanted it to. So it would go up and then come back down here. So that is what our sine function looks like. Okay, let's look at a cosine example now. So again, 2 is our A and 2 is our B. So we're going to use that to help us here. All right, so in cosine, our amplitude is still the absolute value of A. So our amplitude is going to be 2 now. And our period is going to be 2 pi over that B value. And so that's going to leave me with a period of just pi. So it is going to complete one whole cycle in pi. All right, now our intercepts on this one. So for cosine, our intercepts are at a fourth of 2 pi over b and 3/4 2 pi over b. So we know, again, 2 pi over b is pi. So a fourth of that would be pi over 4. And 3/4 of that would be 3 pi over 4. So pi over 4 is going to be an intercept, and 3 pi over 4 is going to be an intercept. All right, and then lastly, we need to know where those maxes and mins are. So for cosine, our max is going to be at 0a, so that would be 2 here. So 0, 2, because that amplitude is 2. Remember, it's twice as high. And then it's also going to happen again, 2 pi over b. So remember, that is going to be pi. And up at 2 again. So we have maxes at those endpoints of our cycle. And then our minimum, remember, is kind of going to be in the middle of those. So the middle of that is going to be half of 2 pi over b, which is pi over 2. And then it's going to be at the negative of a value, so negative 2. So it is at pi over 2 in the middle here, down at negative 2. So this cosine function comes down and goes back. Okay, and then last for this one, we are going to look at a tangent, and then we'll look at 3 of the reciprocal functions as well. Okay, so we've got our a value of 1/2, and our b value here is also going to be 1/2. So if we change the period because of that b value, it looks like pi over the absolute value of b, which would be pi over 1/2. So the period for this one is going to end up being 2 pi. Intercepts for this tangent function, since we've stretched it out in that horizontal direction, we're still going to have one at 0, 0. Whoops. But now, since that period's 2 pi, we're stretching it out in that horizontal direction. That means that the next one is going to be at 2 pi. So we can see those on our graph here. And then it would continue on every other multiple of pi. All right, so our asymptotes now. The vertical asymptotes are going to be the odd multiples of pi over 2b. Well, in this case, 2b is 2 times a half, which is just 1. So it's really just going to be at all the odd multiples of pi. So on our graph that we can see, we're going to have an asymptote at x equals pi and an asymptote, at the odd multiples. So not 2 pi, but at 3 pi. So I am going to just draw my asymptotes in here to kind of help me visualize what my graph's going to look like. And then we have these halfway points. So remember, your halfway points are points that help us kind of figure out where other key features are on here. So these are going to be at pi over 4b. So pi over 4b. 4 times a half is 2. So they're going to be at pi over 2. And then the y-coordinate is the a value. So pi over 2, 1/2. Let's put there. And it's also going to be at negative pi over 4b, so negative pi over 2, and the negative of a, so negative 1/2. So on our graph, it's kind of hard to see that, but it helps me to get the general idea of what the shape of this graph looks like. So I know that it's coming from down below on the left side, and then coming through 0, 0, and going up this way. And it's replicating that over here. And then it continues on through the next one. So we can see the general shape. It doesn't have to be perfect on your sketch, but if you have the key points right, then you're going to get a good idea. Okay, let's look at our 3 reciprocal functions now. Our first reciprocal function that we're going to look at is cosecant. So we have an a value of 3 and that b value of 1/2. So the period for this one, when we're to find the period when it changes, it's 2 pi over the b value, which is 1/2 in this case. So when I simplify that, I get a period of 4 pi. Asymptotes on this one. So remember, that's when a, so in our case 3, cosine of d theta, so x over 2, is 0. So if I graph that and figure it out, my asymptotes in this one are going to be at the x values of 2 pi. So right here. And then continuing on with the the even multiples of pi. So 1 at 4 pi, and then 1 at 6 pi. So I know that those parabola U shapes are going to be in between those. All right. Then we're going to figure out 2 key points that are going to help me to determine where these are. So for this example, I am going to pick a point that's at pi. So if I plug in pi there, cosecant of pi over 2 times 3. So when I plug in a pi, cosecant of pi over 2 is 1, and 1 times 3 is 3. So I have a point over pi up 3. And I know from my cosecant parent graph that the parabola or the U shape from there is pointing upwards. And that same thing would be mirrored in that last, oops, went one too high, that last section. So over here at 3, I would also have one going upwards there. And then I know that in between those at that middle point, so 3 pi, if I plug in 3 pi over 2 times, or cosecant of 3 pi over 2 times 3, I get out negative 3. So this middle section is that U shape pointing downwards from negative 3. So that's what my cosecant graph looks like there. All right, let's move on to a secant graph. So again, on this one, we have an a value of 2 and a b value of 1/3. So 2 pi over 1/3 for our period is going to be a period of 6 pi. So it's going to take 6 pi to go through one whole period here. My asymptotes on this one would be at the x values of 3 pi over 2. So 3 pi over 2, right in between those. And then since my period is 6 pi, it's going to take a whole 6 pi to go through that again. So the next one is at 9 pi over 2. So that's at about here. And then I'm going to have one at 15 pi over 2. So that is about here. So that's where my asymptotes are. And I'm going to pick some key points there. So I can see that one key point is going to be at 3 pi. So if I plug in 3 pi over 3, that's just pi. So secant of pi times 2 is going to be negative 2. So at 3 pi, It's down at -2, and that is that U shape facing downwards from there. And then another key point is going to be 6 pi. And as you may have figured out now, it's kind of a reflection of that. So it would be up at 2. And it would be that U shape facing upwards. So then I can use that to kind of help myself draw the other half of it. So it would look something like this. And the other half that I'm missing over here looks kind of like that. So there is my secant graph. Okay, last example that we're going to look at here is a cotangent graph. So for this one, we have an A and a B value of 2. So my period for cotangent is usually pi. Since we have a B value of 2 here, it's going to be pi over 2 for the period. So what that means is it's compressing it horizontally. So my intercepts are also going to be compressed by that. So now my intercepts are going to be at pi over 4. And then all of the odd multiples of that. So 3 pi over 4 and 5 pi over 4. And then it would continue on after that. So my intercepts are pi over 4 and 3 pi over 4 and 5 pi over 4 and 7 pi over 4. So those curves are going to come through those intercepts. My asymptotes are going to be in between those. So the asymptotes on this one are going to be at pi over 2. So it's going to split those intercepts. And then at pi. And then at 3 pi over 2. And at 2 pi. And then we continue that on as long as my graph goes on. So it looks something like that. So my halfway point, so halfway between the beginning and pi over 4, that's pi over 8. So if I plug in pi over 8 and then use that A value, I know that it's at 2. So it's up here at 2. And halfway between the intercept and the next asymptote would be 3 pi over 8. And that one would be at -2. So that would be over there. So I can see my curve going like that. And then that curve is going to repeat. So I can use those key points to kind of help me continue that pattern over and over again. Again, they go up and down forever. All right, so those are my 6 trig functions graphed. We'll see you next time.